In this video, I'm just going to rework problem 22 out of chapter 3. There was a mistake today in class, and I have figured out what that mistake was. And it's really right here. When I reread the problem, the maximum height above the cliff was 6.74 centimeters, and I worked it as if it had said 6.74 meters. So the grasshopper jumps off the cliff at an angle of 50 degrees, reaches a maximum height of 6.74 centimeters, and then eventually lands 1.06 meters, and this was meters, from the base of the cliff. All right, let's work it again. Our process was right in class, but let's do it with the right numbers. If we look at what's going on horizontally, the acceleration will be 0. The initial velocity is just the horizontal component of the velocity, v0 cosine 50. The initial position, of course, it started at 0 and it ended at 1.06 meters. And there's all our given information about what's going on horizontally. Vertically, we know our acceleration is negative g, or negative 9.80 meters per second squared. We need the vertical component of the initial velocity, v0y. v0 sine 50. We don't know this initial height. That's the big question. We do know the maximum height. The maximum height was 6.74 centimeters above where we started, from here to here, or 0.0674 meters above cliff. And we know that that happens when when Vy equal 0. At the top of the cliff, that's where the vertical velocity is 0. We're really looking at what happened from here up to here. We have a great equation for that. It says v squared is the initial velocity squared plus 2a times the displacement. Since we're working a vertical problem, we'll use vertical displacement. That means we need vertical acceleration, vertical velocities. All right, at this very top point, that's the final, that will be 0. This will be v0y squared. We're going to try and find this. Negative 9.80, and then our displacement is at 0.0674. When I solve this, I get 2 times 9.80 times 0.0674. That's 1.321, and when I take the square root, I get 1.1494 meters per second. But that's really going to let me answer this question, what is V0? I'm just going to use that relationship there. V0y equals V0 sine 50. 1.1494 equals V0 sine 50. And this time, I get that the initial velocity was 1.50 meters per second. Our mistake last time is that we got 15. And of course we were off because of this right here. That's what cost us. All right, the height of the cliff is really pretty easy. We still need to find the time though to get it. So let's go over here and think about this. If I know how fast I'm going, I can figure out some more things down here. V0x is going to be 1.5 cosine 50. Comes out to be 0.9642. So if I use the fact that horizontally we're going at this constant speed, I can use distance equals rate times time. 1.06 equals 0.9642 times t. All I have to do is divide. And I find out that in the air for a time of 1.0994 seconds. I'm carrying a lot of extra places. This isn't my answer, but it's a good stepping stone. How long I'm in the air. If I know how long I'm in the air, I can solve this problem. I'm down to this last equation. And I'm going to plug in everything. I'm trying to find this thing, but I know at this time, 1.0994, the height is 0. That's this point right here. So 0, that's my final height, y0, plus, this was v0y was at 1.15 or 1.494. I'm going to just use the 1.15. The time was 1.099. Half of a is minus 4.9, and then 1.099 squared. Move this to the other side, and I get y0 equals 1.15 times 1.099 minus 4.9 times 1.099 squared. I get 4.6. This time I got 4.65 meters. Again, a little rounding. I think the book got 4.66. I think this morning we got 4.67. That's what, depending on where you round, you can get tiny bits of error, but that's a good answer, and it makes sense. So our initial height was 4.65 meters. All right, I hope just going through it again was helpful. I just really wanted to clear up where we got off. So read problems carefully. That's what we learned there. All right, that's the end of this video.